Here we go. Here's bell work. In bell work here, I've got a graph. It is obviously either secant or cosecant based on the parabolas. Our job is for you to write 4 different equations that would give you that different graph. There are lots of different ways to make graphs. You can give them lots of different adjustments and make it look like the same thing. Okay, let's try to do that here. Okay, so if I'm graphing this, that's the same one you had in bell work. We're just going to do it in Desmos. We're going to try to write the equation. Okay, so Annika, what was your first one? Did you do secant or cosecant?
I was trying to do
Cosecant. So let's graph sine because it'll be easier to make that transfer. But cool, you did cosecant, so we're doing sine. All right, cool. There's my graph. Megan, what's something I have to do with that graph to get it to match the other ones? Up to 3. Good. We're going to take that thing and move it up to 3. Okay, so we definitely need that to happen. Cool. What else do I need to do here? Yeah, I'm seeing fingers. The flip. We've got to take that graph and we have to flip it. So we got to put a minus sign in front. If I threw that minus sign in front, now you can see that everywhere the sine graph has a max and a min, then my cosecant graph happens. So if I change this, instead of it saying sine, and I made it say cosecant, now it's the correct graph if I just did the reciprocal of it. Good. There is one graph. Okay, let's do it again. Okay, so we're going to go with sine x plus 3 again. But we're going to do something different. What can I do differently with that graph? Sophia, what do you do?
I did a horizontal shift of
2 pi. So if I did this and I went plus or minus 2 pi?
Minus.
Sure, minus 2 pi. Look how much different that was. It was exactly the same. Because if I shifted 2 pi, the period length is 2 pi. So if I just move it over 2 pi, it does absolutely nothing. And so then what else would you have to do to this graph? Flip it. Yep, we're touching. So instead of sine, we could make it cosecant. That's the most boring thing that we could have done. But yes, that also works. Good. Aaron, you got something else for us? I could add 2 pi. All right, I'm done adding 2 pi's. I could add 4 pi. That is definitely something I could do as well. Yeah. Hush. What if I wanted to take this dot right here and just move it to right there? So not flipping it, but moving it. How much would I need to move it? Pi. Which direction do I need to shift pi? Either way, because I could either move it left or right. So if inside these parentheses I went x minus pi, okay, now they're touching. So instead of sine, I could do cosecant. Okay, cool. It matches up. I could do the exact same thing, but instead of minus pi, we could have done plus pi. Yeah, it didn't change anything because I just shifted it back the other direction. All of those work. Okay, let's get into a little bit different. Let's go with cosine. Okay, so cosine. Sorry. What am I hitting? I am hitting the wrong button. Cosine of x. And then let's go to plus 3, obviously, because we need that. So we're up to here. That's not matching up either. Kara, what could I do with that to get it to match up? Shift it left or right? Which way you want to shift it? Let's shift it left. So if we shift it left, how much do I got to shift it? Good. Plus pi over 2. So in here we're going plus pi over 2. Cool. It matched up. That's cosine. And so we could make that then secant, and it would match up. Okay. She said we could go left or right. So let's just do one more. Instead of going left, let's go right. How much would I need to shift that thing to the right to get it to match up? 3 pi over 2. 3 pi over 2. There's lots of different ones. We could go on forever and ever. There's literally a limitless amount of equations we could write here. We could just keep adding 2 pi. We could flip it and then shift it and then do a whole bunch of different things. There's a lot of different equations that could match up. Your job is to find one of them that works. Kind of makes sense with how we did that. Here we go. We are graphing sine or tangent and cotangent. We're going to start off by filling in this table just like we did with sine and cosine. We're going to go fairly quickly. You just got to know your basic stuff here. If we are doing tangent, we're going to start off by doing tangent because if we do tangent, then cotangent, we just got to flip it. Okay, so for tangent, we are doing whatever tangent is at 0. Okay, so remember what tangent means. Tangent means y over x. So if I'm right here, it's the ordered pair 0, 1. What is y over x? Oh, I wrote down the wrong ordered pair. Act like I didn't do that. Act like I wrote the correct ordered pair, 1, 0. And now do tangent. It's 0, my fault. It's 0. Then we're doing pi over 4. So if we're doing pi over 4, we're right there. I got radical 2 and radical 2. So what's that going to get me? 1. Then we're doing pi over 2. Pi over 2 is right there. That's the ordered pair 0, 1. That is undefined because it's y over x. It is 1 over 0. It is undefined. 3 pi over 4, we're in this quadrant. It's radical 2 over radical 2, but what's going to be different this time? It's -1 because my x is negative and my y is positive. At pi, we're over here. It's at the ordered pair -1, 0. Y over x, it's 0 over -1. It's 0. 5 pi over 4, I'm down here in the third quadrant. +1 because my y and my x are both negative in that quadrant, so it's +1. 3 pi over 2, I'm down here at the bottom. It is the ordered pair 0, -1. Y over x, it's going to get me undefined. Hopefully you can see a pattern that is happening here. 0, 1, undefined. -1, 0, 1, undefined. And so if we just continued that pattern out here, it's going to look like this. If you don't believe me, you could have kept going, but it's just that. It goes back and forth. Undefined, -1, 0, 1, undefined. -1, 0, 1, undefined, and so on. Questions to that point? Let's graph it. So at 0, I'm graphing 0. At pi over 4, I'm graphing 1. So not pi over 2, but somewhere in between there, I'm up there at 1. At negative pi over 4, I'm down here at -1. So it's kind of like a 3-dot little guy there. At pi over 2, it's undefined. What am I going to graph if I'm trying to graph something that is undefined? Vertical asymptote. So I have a vertical asymptote right there at pi over 2. I got another one there at 3 pi over 2. Another one at -pi over 2. And -3 pi over 2, and so on. I got dot, 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 dot. There's my dots. Think about that. I've got those 3 dots in vertical asymptotes. And remember what we do with vertical asymptotes. We get really close to them, but we never actually touch them. So what kind of shape do you think I'm going to make in between those 2 lines? Show me the arms. What do you think? It is going to be very cubic-like. Okay? So you can kind of see that shape. So again, here it is. If I'm graphing tangent x, there is my graph. Here it is at 0. Pi over 2, I have an asymptote. At negative pi over 2, I have an asymptote. It looks very much like a cubic graph. Here's what a cubic graph looks like, remember? It's not the same. It doesn't have quite as much bend to it, but it's pretty similar. Okay? Pretty similar looking shape there as a cubic graph. So let's do that. So I'm going to start down here. Go up through. Boom. 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 There's my graph. Makes sense on tangent. That's a tangent graph. Let's graph cotangent. The good news with cotangent, if I know what tangent is, cotangent is just the reciprocal. Okay, so for example, I've got 0 right here. What is the reciprocal of 0? Undefined. Because 0, we got 0 because it was 0 over 1. If I do the reciprocal of that, it's 1 over 0. It's undefined. If I do the reciprocal of 1, that's 1. The reciprocal of undefined is going to be 0. Okay, because again, this was 1 over 0. I flip it at 0 over 1. That's 0. -1, undefined. 1, 0, and so on. It's just flipping these guys. Once we've got that, we're going to put it on our graph. So what we're saying here is at 0, I am going to be undefined. So right here in the middle of my graph, I'm going to have a vertical asymptote line. At pi over 4, I'm going to be at 1. At pi over 2, I'm at 0. At 3 pi over 4, I'm here at -1. And then at pi, I have another asymptote line. And at 2 pi. And at -pi. And at -2 pi. Make your dots. What's the difference between a tangent graph and a cotangent graph going to be, do you think? Yeah, they're flipped. It looks like a tangent graph, but it's been flipped. If I jump into Desmos here, there's tangent, there's cotangent. Same thing, it's been shifted a little bit, and it's been flipped. It makes really pretty graphs when you graph them at the same time. Oh, it's very nice. Questions so far? We know our basics. Let's point out some characteristics. Okay, looking at this tangent graph, talk with your neighbor and decide what do you think the period length is on that tangent graph. For sine and cosine, our period length was 2 pi. What is our period length going to be for tangent? A single pi. Okay, because look at this graph. I go to the right pi over 2 and the left pi over 2, and that's my asymptote lines. Everything you want lives in between these two lines. Okay, that is 1 pi because you went a half pi one way and a half pi the other, and then it just repeats. Okay, and so every pi I have a period length. Tangent graph, what does it start with? What is beginning at 0? Is it an asymptote line or is it that middle point? The middle point, the vertex. It starts with the vertex, the middle. And then a tangent graph, very basic. We start from the bottom and we go to the top. From the bottom to the top. Go with tangent. Cotangent. What's my period length going to be with cotangent? It's pi. It's still pi. This time we go from 0 to pi to make our graph, but yeah, my period length is still pi. Tangent and cotangent both have a period length of pi. What do we start with on a cotangent graph? Is it a vertex point or is it the asymptote line? Asymptote. We start with an asymptote for cotangent. And we go from the top to the bottom. We start up, we go down. The cotangent graph. Some simple memorization things. You got to memorize this stuff. You got to know it back and forth in your brain. You got to be able to put it out there. Let me do some quick things. When we talk about sine and cosine, it is 2 pi. But now we're going to tan. Okay? Tangent. If you're going tan, I'm thinking I'm going to the beach. I'm trying to look good. If I'm trying to look good, I'm not eating 2 pies anymore. Now I'm just eating 1 pie. Okay? Just 1 pie now. If I'm going to the beach, I'm going to tan. Okay? When I go tanning, you would look silly if you didn't tan the middle of your body. Don't forget to tan in the middle. When we make a tangent graph, you got to put a dot in the middle. Otherwise, you look kind of goofy. Okay? And then the other thing is if you go to the beach, you're going to get more tan. You start off not tan, and you get more tan as you go. Okay? We start down, we go up. All three of those things you got to have in your brain. Cotangents. Yeah, in the middle, that's when you're going to get that pie. Yeah, you got to get that pie right there in the middle. Yeah, it makes total sense. All right, let's graph it. So unlike sine and cosine where we kind of eased into it, we're jumping in. Okay, we're doing all these things at once, but you already know how to do them all. Okay, it just has to be put in a different way. Okay, so we're doing amplitude, period length, vertical shift, horizontal shift, and in the end, we're going to do domain and range. So we got a lot of different things to do here. The good news is you already know how to do most of these things. Amplitude's a little bit different with tangent graphs. It's not necessarily the top and the bottom, but it is just our stretch number. What's our amplitude going to be here? 2. That doesn't change. It's 2. Period length. I'm doing the base of a period length of a tangent graph. What is our base period length of a tangent graph? It is 1 pi. We're going to the beach. E less pi, 1 pi. Vertical shift is down 1 because of this guy here on the end. Horizontal shift is a nah. Let's graph it. Okay. When we graph tangent and cotangent, it's not going to be crazy different. Okay. But when I make my graph, I'm going to stretch it a little bit more, the same amount to the, or I'm sorry, a little bit more balanced. Notice that I have a little bit more space over here on the left-hand side. When we graph tangent and cotangent, it just sometimes ends up a little bit more to the left side. So I just use that as I set it up. Cool. There's my graph, just like we did with sine and cosine. This probably isn't the perfect way of doing it, but it's going to keep it the same each time. We're doing 4 hash marks. Okay. Make your 4 hash marks. So 1, 2, 3, 4. I don't spread them out quite as much with tangent and cotangent. You could have. I just try to keep it smaller. My period length is pi, so that 4th hash mark is going to be pi. The middle one is half of that. It's pi over 2. This is half of that, so it's going to be pi over 4. And then 1/4, 2/4, 3/4. Period length, everything's the same. Once I've done my period length, what do we normally do next? Midline. So I'm making my midline here. My midline is at -1. So I'm going to go down here to -1, and I'm just going to label it. Okay? If you want to put maybe a couple dots here to give yourself a visual, not the end of the world. I just hate drawing like a solid line here because with sine and cosine, it kind of was the middle. It was based around that line. It's not so much here. So there's my midline. Then I could do amplitude. And again, amplitude's kind of strange here. Where's my top going to be? 1. But it's not really the top because a tangent graph goes up forever. It's never going to stop going up. So it's not the top, but it is how much I'm going to stretch. So I'm going to stretch up to 1 because I went up 2. And then I'm going to stretch down to -3. Again, if you want to just do some real light dots so I don't forget, that's great. But it's not really a line. It's just how much I'm stretching. Great. Now we're going to graph it. Okay, we did our midline, we did our amplitude, now we're going to graph it. And this is where you just have to think. I don't have a better way of doing this than thinking. This is a tangent graph. What is going to happen at the beginning of a tangent graph? Am I going to make an asymptote line or a vertex? Vertex. Tangent is vertex. Okay, so on the midline, so down here at -1, I'm going to put a vertex point. Okay, that is the middle of my graph. My period length is pi. That's the center. So how much do I need to go to the right to make my asymptote line? Pi over 2. Think about what I'm just saying. Okay, I have 2. This is a full period length. I have 2 asymptote lines and a tangent graph. Okay, we know that the period length is pi. So to go from one side to the other is a pi. Well, we are starting in the middle. So if we're starting in the middle and we're going to this side, I need to go half a pi. And so my asymptote line is going to be over here at pi over 2. That is where my asymptote line is going to be. Think, you made 4 hash marks, but the middle is at 0, so I need to go 2 hash marks. I need to go half of that. It's at pi over 2. So where is my other asymptote line going to go? -pi over 2. I went half a pi one way, so I got to go half a pi the other way to get me a full pi. So I need to go 2 hash marks. 1, 2. I can call that -pi over 2. Make my asymptote line. I'm graphing tangent. So if I'm got all that, now on these in-between hash marks is where I'm going to make my points. Okay, my stretched points. So right here it's at this one, at pi over 4 and -pi over 4. Which way does my graph go? Do I start bottom or do I start at the top? I start at the bottom. So I'm going to be down here at -3. Don't forget to stretch it. Okay. And over here, I'm going to be at +1. So I'm starting down through the top. There's my graph right there. This graph would keep repeating forever. Okay. You would have another one that goes right here that would do all of this. And you would have another one over here that would do the same. Okay. We are graphing a very basic version of just one period length. I might ask you to graph 2 or 3. You can do that. It's just repeating. Questions on that part? That's our tangent graph. Domain. All real numbers. X cannot be. I have asymptote lines. If I have asymptote lines, it can't be something. Where is an asymptote line? So we're going to say X cannot be pi over 2 because I have an asymptote line. And then we are going to add to that however long it takes for me to get to my next asymptote. How often do I have an asymptote line? Every pi, because that's my period length. So every plus n pi. Every pi, I'm going to have one. So pi over 2, 3 pi over 2, 5 pi over 2, and so on. Okay. It also helps me get this one because n can be negative. What about my range? All real numbers. That one's easy because you have arrows going down and up forever. My range is all real numbers. It goes on forever and ever and ever. Questions on the first one? Let's do it again. Flip it over. Number 2, we're doing amplitude, period length, vertical shift, horizontal shift. Do that for me real quick. See what you can do. Here we go. Amplitude. Matthew, what's my amplitude going to be? 1/2. What about period length? Matthew, what am I going to start with? We're going to start with pi. That's our base period length. And then what do you got to do with it? Multiply by the reciprocal. So multiply by 3. My period length is 3 pi. Vertical shift. Sam McCain, what's my vertical shift going to be? Up to. What about a horizontal shift? None. Where would it look like if I had one? After the X inside the parentheses. And we'll do domain range here in a minute. Okay. Cool. There's my graph. I made my graph. I went up 2, so I drew a little bit more up top. I do my 4 hash marks. Okay. I'm going to label my four hash marks. This 4th hash mark is going to be 3 pi. So, Megan, if that one's 3 pi, Megan Copeland, what's this middle one going to be? 1.5 or 3 pi over 2. Yep, you're good. 3 pi over 2. If that one's 3 halves, what would the first one be called then? Good. 3 pi over 4. And then count 3/4. The next one would be 6/4. So the third one would be 9/4. Remember, it's just taking the first one, multiplying it by 3. I did my period length. Great. Next thing I'm going to do is my vertical shift. My vertical shift is up 2. So I'm going to go up 1, 2. Boom. My amplitude is 1/2. So ugly, but that means that I'm going to go there and there. I don't have to put lines here. If I'm just smart enough to think my way through it, I can. If you want to draw some lines, hey, that's the bottom line. That's the top line. This is the midline. Go for it. You don't have to, though. Okay. To me, it's a little bit more, it's easier if it's not as cluttered to me, but that's up to you. All right. We did that. Now I'm going to graph it. It's a cotangent graph. What happens at the start of a cotangent graph? Is it an asymptote or is it a vertex? Asymptote. So I'm starting right here at 0. I'm going to make an asymptote. If I have an asymptote at 0 and my period length is 3 pi, when is my next asymptote line going to happen? At 3 pi. At 3 pi is when my next one's going to happen. So obviously my middle point is going to happen in the middle of that at 3 pi over 2. So my middle point right here is going to go at 3 pi over 2, and it's going to be up at my midline. So I'm going to be up at 2 at 3 pi over 2. There's my middle point. It's a cotangent graph. So where do I start? Do I start down or do I start up? Up. Cotangent graphs look like that. So I'm going to start up. So up here, I'm going to go up a half because that's my amplitude. And down a half because that's my amplitude. Start up, go down. That is my graph. Again, it would repeat forever and ever and ever. We don't have time to graph forever and ever and ever, so we graphed one period length. Domain is going to be all real numbers, but x cannot be. Lydia, where is an asymptote line? At 3 pi, okay? So you could say that. I'm going to say 0, but it doesn't matter. I'm just doing it because keep it clean. But 0 plus, and then how often, Lydia, do you have a asymptote? Every 3 pi. So it's 0 plus 3 pi n, 3 pi, because that's how wide it is, and then times n. Obviously, you don't need a 0 plus. You could just write 3 pi n, but that's how often I have a asymptote. So it's at 0, it's at 3 pi, it's at 6 pi, it's at 9 pi. I'm multiplying by n is going to multiply that out. My range, all real numbers. Questions on 2. Let's do one more. Again, I'm giving you tough ones, okay? Number 3, it's tougher. If you can do 3, you can do every one I'm going to throw at you. Okay, I'll talk about a scale on a 1 to 10 scale, how hard they could be, 10 being the hardest. I'd say 3 is probably like a 7. And if you can do that, then on a test or a quiz, I'm probably giving you like 5s and 6s at the highest. So 7 should be the hardest one we could do. Go ahead and set up your amplitude, period length, vertical shift, horizontal shift. Amplitude, Herman, what's my amplitude going to be? 1. What about your period length? Pi, good. Don't forget that it is 1 pi because we're tanning. Vertical shift here, point for me, careful. Which direction are we going on this graph? Which way are we shifting? Are we shifting right or are we shifting left? Oh, I said vertical, didn't I? Sorry, vertical's down 3. My bad. Vertical, down 3. Now let's go to horizontal shift, the one that I was actually talking about. Point, which direction are we shifting horizontally? Why am I going to the left? Max, talk me through it. Yep. Yeah, we talk about factoring out that negative. If I factored that out, it'd be like negative, and then x plus pi over 4. That pi over 4 is taking me to the left. Don't forget about that. That's kind of funky, but we can do it. Does this negative matter? Yeah, it's a tangent graph. It's going to matter. What is that negative going to do to my graph? It's going to flip. Don't forget to flip it as well, because we do need to flip here. Okay, that negative still flips me. It only doesn't matter when I'm doing cosine and secant. All right, let's put all of that on a graph. I need to go down 3, so I'm going to make this thing shifted down 3 quite a bit. Here we go. We are doing period length first, so we're going to label. Oh my goodness, I keep erasing it. We're going to label our period length. So this one is pi. This is pi over 2. This is pi over 4. This is 3 pi over 4. Then I'm going to do midline. My midline is down here at 3. So I can go down here to 1, 2, negative 3. That's going to be my middle line. My amplitude is 1, and so I'm being stretched up 1 and down 1. Again, I'm just doing a real basic dotted line there just to kind of remind me more than anything else. Great. Now let's get to the hard part. I'm graphing tangent. What happens at the 0 of a tangent graph? Vertex or asymptote? The vertex, but it's not going to go there. Why is it not going to go there? I'm shifting to the left pi over 4. So how many hash marks do I need to go if I'm going to the left pi over 4? 1, because according to our scale, 1 hash mark is pi over 4. So I'm going to call that negative pi over 4. I'm going to put a dot on the middle. Okay, so my middle is down there at negative 3. I made my middle dot. Now I'm going to make my asymptote lines. My period length is 1 pi. My middle dot is at pi over 4. Negative pi over 4. Where is my asymptote line going to go? At positive pi over 4. That's a half a pi away. I'm 1/4 to the left. So if I go over 2/4, so over a fourth would get me to 0, go to over another fourth gets me to pi over 4. That is the right side. My period length is pi, so half a pi to the right. What about my left asymptote line? Where's that going to go? Negative 3 pi over 4, because I'm subtracting a half. That is where my asymptote on this line is going to go. Again, if I go all the way across, if you were to measure from here to there, it should be 1 pi. If I measured from here to there, it should be a pi over 2. And then both of those things are true. It is a tangent graph. So I'm here in the middle, go over a hash mark, I'm up there, boom, that's a dot. I'm going to go over here, go down, because remember, it was flipped. So a tangent graph is going to now start up and go down. It's going to look exactly like a cotangent graph. Okay, don't forget to flip it. Then I'm going to graph it. Starting up, through, down there. There's my graph. Domain, all real numbers. X cannot be. Aaron H., where's an asymptote line here? At pi over 4. X cannot be pi over 4, and I'm going to add to that however long it takes me to get to another asymptote line. So how far is in between my asymptote lines? Pi, because that's my period length. So plus n pi. If I'm doing range, what's my range going to be? All real numbers. This is something you just got to practice. At first glance, it's not real tough, but if you don't practice it, then your brain's going to start melting when you do them again, okay? Again, number 3 is tough. If you can handle 3, you can handle them all, okay, for the most part. Look at number 7. I just made a mistake when I was copying this worksheet. I forgot to throw parentheses around that x and the minus 3 pi over 4. If you're looking for a challenge, 7 is it, okay? 7 might be even a little bit tougher than 3, but it's a good one. Again, if you can do 7, you can do them all, okay? For tomorrow, your job is to do 3 out of those 4 graphs. I do not care which 3, but do 3 of them, okay? You're graphing them. You're labeling domain and range for each. Everybody understand what you're doing? Get that done for tomorrow.